Okay, let's get started. So a little bit of housekeeping before we dive in. So if you've got any questions, I welcome questions at any point. Just raise your hand. The only thing I would ask is if you could just hold on before you kind of shout out your question. We've got Q here at the front with the microphone. So just for the benefit of everyone else in the room, just so that they can hear what question you're asking, and then hopefully hear a reasonable response. We've got Sam in the front, so we guaranteed a reasonable response. So thank you all for coming. I appreciate it's the first session after lunch, so maybe an ideal time for a little nap. And I'm guessing that most of you are here because you either want to know about CI/CD or you already know about DQMH and didn't want to go to Darren's session, which they scheduled at the same time. So welcome to the what, why, and how of CI/CD. My name's Chris Roebuck. I originally wanted to call this presentation, It's Okay to Take Baby Steps. And the reason for that is I see a lot of presentations around CI/CD. I get a lot of people asking me about it, and they're like, I'm not doing CI/CD yet. How do I set up a Docker container? And you're like, what? Like you're literally diving in at the deep end, and you're going to have a horrible experience. What I'm going to promote, and it says level intermediate at the bottom, what I'm actually promoting is that we could take some baby steps. We could actually start seeing what is CI/CD, what are some steps that I could take to actually start to include it in my workflow without diving in at the deep end and doing what is actually some fairly difficult stuff. So, background on myself, my name's Chris Roebuck. I'm a new hire relatively at NI. I've been with the company for 8 months now. Don't worry, I'm not new to LabVIEW. I've been around. I was described as a veteran this morning, which apparently just means I'm old. But what you should know is I'm a huge LabVIEW geek. I've shown this for years. That was actually a birthday cake that somebody made for me. And I love the fact that they put the B-U-C-K in uppercase. On the right, about 10 years ago, my kids said, hey, Dad, we want to go to the US and do something exciting. They thought they were going to Disneyland. I brought them to NI Connect. So, what are you going to get from this presentation? Hopefully you're going to get to understand what CI/CD is and why people use it. I'm hoping you'll get a taste for some of the things that you can actually do and take some baby steps towards implementing it in your own workflows. So, quick raise of hands, show of hands in the room. Who's already doing CI/CD? Okay, so if I make a complete mess of this, please stand up and tell me, hey, Chris, you got that wrong. So let's start with the what. And apologies, there are a couple of slides in here that are a little bit word heavy. I'll try to keep those to a minimum. So what is CI/CD? Continuous integration, continuous deployment. I sometimes hear continuous delivery. It means different things to different people, honestly speaking. But let's do a little bit of a terminology. So if I take the dictionary terminology or the dictionary definitions of those words, continuous, without interruption. When I looked, the first thing that actually came up, the definition of continuous was continuous, without interruption. Integration, combining things together. That could be combining libraries in software, combining pieces that fit together to make some device under test. It's bringing together the constituent parts of an end product. And then deployment, actually bringing that resource into use. So it might be building an executable from a software application that consists of several libraries. It might be bringing the parts of an engine together and then installing that engine in a vehicle. But it can also refer to a set of tools. Like I say, people think different things when we talk about CI/CD. It can refer to a set of tools, practices, and even mindset around the automation of the process, testing, building, deploying software, and the potential for improvement that that can bring. Okay, so that mindset thing kind of gets people a little bit nervous. Like, well, what does that mean? Does that mean I've got to change the way I work? CI/CD absolutely requires collaboration. If you're the kind of developer who sits in isolation and doesn't talk to the rest of your team and communication is poor, that kind of silo mentality, then honestly, it's going to be a jarring experience. CI/CD is around working together with your fellow developers, following a process, and sharing the responsibility for the assembly of good, high-quality code. That sounds scary, doesn't it, I think? Focusing on a streamlined process, which reduces errors and ultimately accelerates the delivery of high-quality software, sounds a bit MBA-like. So if we look at like a classical team-based workflow, and I've worked in plenty of places like this where, you know, there were 3 developers. They didn't all look like me, but there were 3 developers and we all just sat there churning out code on the thing that we were working on individually, and then we would kind of just blindly commit to a repo, blindly push to a repo, and somebody would do some testing of that code. Meanwhile, we'd all moved on to the next thing that we were going to be working on. And then all of a sudden QA would come up, quality assurance would come along and say, hey, you know, that build that you did 3 weeks ago, it didn't work. And by this point, I've written another 300 VIs or a TestStand sequence, whatever it is. And it's like, oh, okay, now I've got to fix something, but we've already moved on from there. That was kind of the way a lot of software was honestly, you know, who's worked in an environment like that? Okay, thank you for your honesty. And it's not fun. A more modern-based approach is that we have developers collaborating on a project and they are testing at a higher frequency. They are integrating at a higher frequency. They are making fewer changes in between individual builds. Therefore, they have that ability to almost shrink down what could be the cause of problems as problems are found during testing, during the build process. We're going to dive much deeper into this later. So that line around automating the process of testing, building, and deploying software. What does that mean for LabVIEW? Well, in terms of LabVIEW, that means unit testing. Who's doing unit testing? Okay, awesome. Wow, okay. That's a good show of hands. So we're using something like Unit Test Framework from NI, or maybe we're using the JKI tools, Karaya or VI Tester, but we're doing some kind of functional testing of blocks of our code. So whether it's algorithms, whether it's some kind of driver that we're testing, we're doing some kind of functional testing. Maybe we're using VI analyzers, so we're perhaps doing static code analysis. We're looking at the actual structure of our block diagrams. We're checking them for, well, we're going to go into what we might be checking them for, but we're looking at the block diagram, we're looking at the properties of a VI, we're looking at the front panel of a VI, and we're applying some guidelines to them. So we're doing that automatically. Maybe we're building PPLs. Maybe we've gone against Darren's advice and we've decided that we do want compiled libraries that we can reuse on different projects. So we're maybe building PPLs, source distributions if we're using TestStand. There's a bunch of stuff that we might be doing as part of this automated process, building some packages, building some executables. Chances are, if we have a large or even a medium application, we're probably going to be doing several of those things. We're probably going to want to do VI analyzer, unit test, but our actual software application itself might be made up of multiple PPLs, an executable, some reuse packages that are in NIPM or VIPM. So we're probably going to be doing multiple items from that list. I'm going to show you how to do that in a little while. The why. Okay, software quality. Hopefully we're all aware of this, but getting early feedback, discovering bugs early in the process, it's just easier to fix. It's less costly from a time and money perspective. If you have a bug that actually makes it out through testing and into the final delivered product, it is 100x more costly to fix that bug at that point. It seems obvious, and yet how often do we push all of that testing, all of that integration, VI Analyzer, we push it right to the end. A little sidetrack, anecdote, story, whatever you want to call it. I joined a team of developers back in 2008, and they were working on a project to test a satellite. This is like something that's going to go in space, and if it goes wrong, it's going to fall on your house. And they were working on this product. There were 10 developers, and they'd been working on it for 2 years. That's 20 man-years worth of effort. And I asked them, I said, hey, so guys, just out of interest, how long does it take for you to build your test application? And they said, well, we don't know. We've never built it. Like, what? You've 2 years worth of development and you've never built it? So I said, stop writing code. Let's go build. And they tried to build. It was LabVIEW 8.0. It was TestStand 4, and they were using object-oriented programming, which sadly didn't work in TestStand 4 and LabVIEW 8. And they could have discovered that problem on day 1. They discovered it on day 700, and it took a further 3 months of rework to fix that problem. They could have found that on day 1. Okay, they just pushed all of the testing to the end. They were so focused on writing code to satisfy requirements, they didn't satisfy the number 1 rule, which is you've got to have something that that is a product at the end of it, and they just pushed everything to the end. And they build satellites. These things fall on your house. So yeah. Peer review, linting. So these are things that affect quality. So sitting down with a colleague and asking them, hey, review my code. Tell me what's good or bad about it. In other languages, the phrase linting is often used to look at the syntax, look at the textual code that you've written, and to apply guidelines to it. In LabVIEW, we have VI Analyzer. It can check for style. So if you've got messy block diagrams, wires going under things, just code that's difficult to read, it can tell you that. If you've got performance issues in your code, maybe you're using the value property, using property nodes and using the value property to update something rather than a local variable, that potentially has a performance impact. Maybe you are building arrays by appending elements rather than pre-allocating an array. It can tell you about those things. You want to know about them. And finally, it can identify what I call dangerous constructs. You've never heard that expression before? Go seek out my presentation about VI Analyzer. Dangerous constructs is basically code that works today, but something might shift in your environment or in your use case that means that code will stop working, or at least stop working in the way that you expect it to work. VI Analyzer can absolutely help you identify things like that as well. So that's something we want to do. So it can identify style issues. Current VI's path qualifies. Who uses current VI's path? Okay, a couple of hands. So maybe you may have spotted, but the behavior of that changes between code written in the development environment and when you build an executable. Its behavior changes. The path that it returns will change. So that would qualify as a dangerous construct. And then you might be doing some less than performance stuff when you're building arrays rather than pre-initializing. So it can do that. It can find all of that stuff. Functional testing, using unit test framework to check edge cases, the robustness of your algorithms, etc. Automated testing. These are all things that can improve quality, reducing manual errors. I'm going to zip through a few of these. And there we go. Increased collaboration. CI/CD encourages collaboration. And then finally, developers get to keep on working. So one of the things we'll see towards the end of this presentation is that CI/CD can be a somewhat asynchronous process, with the idea being you as a developer make some changes, write some code, and then that code goes off to be tested. You're not waiting necessarily. You're not waiting necessarily on the output of that testing. You could actually continue to be productive. Your machine is not locked up doing some build, running some tests. You can carry on wiring the wires, doing the stuff you do, and then receive the result of that testing at a later point. Other thing I want to touch on, this is not my, I don't even know if that's a word, but Steve Watts, a friend of mine, gave a presentation years ago, and he talked about immediacy and getting quick feedback, rapid feedback. We use LabVIEW, and we get immediate feedback at edit time. If you wire something that shouldn't be wired together, LabVIEW shows you immediately, okay? It says, hey, those don't match. And honestly, it's one of the reasons why I love LabVIEW. I like to know if I've done something stupid straight away rather than when I've done the linking and the compiling like I have to do in C++. But what about the breakages that we can't see, the faults in our code that we can't identify just visually? Well, we've got these tools like I've mentioned, unit test framework, VI analyzer, application builder, VI tester, etc. So we got those tools. So we've got an immediate feedback when we're writing code. We've got these tools that can give us feedback about the code that we've written, but it's not enough to just have good tools. Because, and this is how a lot of people work, I see this an awful lot. For anybody who's been in my presentation before, by the way, Bob is a real person. The name's been changed to protect the innocent. Bob is a real person, and I'm sure you've all met somebody like Bob before. Bob is the guy that when you say, how much LabVIEW experience do you have? He tells you he's got 10 years. Actually, he's got 1 year's experience 10 times because he never learns. So why, when we've got this immediate feedback, why do we work like this then? So we've got the main branch in our repository. Chris, being me, because I'm a diligent developer, I pull from the repository, I make a code change, I do some commits, and then I push my change back to the repository, and then I do another code change, and lots of frequent commits, and I'm always updating from the repository to make sure I've got the latest code. Bob checks out version 1 from the repo, and he works on it for a couple of weeks, and then he makes another commit. You know, he's got 500 modified VIs at this point. And then Bob goes on holiday for 2 weeks and sits on a beach. And then he comes back and he commits some more code that just happened to be on his PC. And then he wonders why when he tries to merge it back in, he gets huge merge conflicts, okay? Why would we work like that when we have that immediate feedback in LabVIEW? Why would we not want to get immediate feedback about style, performance, and our ability to build our application? Okay. Another example of how Bob might work is that, you know, he's a lone developer on a feature. He checks out the code and he makes commit after commit after commit after commit. And then finally, after 200 commits, he tries to merge back in, and there's other stuff has happened to the repo in the interim. And, or even worse, at that point, he runs Application Builder. At that point, he runs VI Tester, and his VI tests fail, his Application Builder fails, and he says, oh, okay, I wonder which of those commits was it that introduced the error? And honestly, you've got no way of knowing. He's going to have to trawl through each of those commits, see what VI's changed in each of those commits in order to resolve that problem. It's an unhappy mess. So let's get rapid feedback about style, functionality, and the status of our build, which it should say there, and I've been absent. So let's have something that looks a little bit more like this, whereby, you know, we are doing testing, we're making commits, we're merging back into a main, and we're doing testing. When we do our pull requests, we're testing our code, and, you know, we're frequently pulling from that repo as well. We're getting the benefit of the changes other people have made, and we're making sure that they integrate with our software, that we don't get any conflicts. And if we do, we're solving them in our branch. We're resolving them. We're taking responsibility in our branch, fixing it there before we then try to merge back in on that right-hand side. So more rapid feedback. So we've got some requirements. We're starting to build some requirements here. We're continuous, collaboration, automation, integration, testing. So how? How are we going to do all of this stuff? Well, going to introduce something called command line tools. I know some of you are doing CI/CD, so you'll know about this and you'll find the next section probably not interesting, but a core part of continuous integration is automation. The act of running tests, build processes automatically. We want to keep those things generic though, if we can. So we want to be able to pass arguments in to those activities such as application builder, VI tester. We want to be able to pass parameters into those functions, those activities, so that they behave the way we want. They test the things that we want to test. They build the things we want to build. So an example there. Application builder. Application builder, we can call from a command line interface if we want the output to be an executable or a PPL or a source distribution. It has a couple of inputs into it, such as the project path and the build specification. So we can give those inputs to application builder and it will build us an executable or a PPL or whatever our build specification determines we want to build. So we're keeping the actual activity of application builder fairly generic. Same thing with VI tester. VI tester has an API. We could call it from a command line. We can pass in a project path and it will run the test that it finds in there and give us a report and say, hey, your tests pass or your tests fail. So automation. So what is the command line? If you've never seen one, it's something that looks like that. You might be using a bash shell, you might be using PowerShell, you might be using terminal. Do we have a question? Nope. Sorry, I thought I saw a hand. So we might be using something that looks like that. I think it's pretty cool. It makes you look like a real developer, yeah?
That's scary.
Yeah. So, it is scary. Also, if you've used any of the Git clients, and depending on what it is you wanted to do, command line can be really fast. I use the command line, I don't use a Git client, it's just what I'm comfortable with. So that's what a command line looks like, and we're going to use that to send those arguments, those parameters, to things like VI Analyzer, VI Tester, etc. So, in terms of command line interfaces, LabVIEW has a CLI. It's had it since 2014, and it allows you to do things like run VI Analyzer configurations, run unit tests, execute build specs, run VIs, mass compile, some interesting stuff you can do. Not all of the parameters are exposed. In fact, there's a couple that are kind of missing really. But it's an option to be able to send command line arguments to LabVIEW and have it do those things. We'll see an example of that in a little while. And it allows you to then receive exit codes back from it saying, hey, those tests pass, or that build failed. You get information back from it. So an example of a command line might be execute build spec. It's got an input, which is project path. There's some optional inputs as well. Or run VI Analyzer, and you provide it with a VI Analyzer configuration file path. It will run the VI Analyzer tests defined in that configuration. You can also do custom commands. There's a link there. Go read it if you want to do some custom stuff. Actually, what I do, and Sam, do you do this? Okay, cool.
Yeah, GCLI.
GCLI. Okay, so my friend of mine, James McNally, Wiresmith Technology in the UK, built an amazing tool, I'm going to say 13 years ago, called GCLI, a series of API methods. They're on the palette. They provide a command line interface, and effectively you're going to write code using those functions, build your own code that can accept command line arguments, okay? It allows you to provide feedback to the console during operations so you can see what's going on. You've obviously written the code, but you get to see what feedback is coming back to the console. And again, it can pass exit codes to confirm the outcome of your operation. So you might do something like that. So that's a piece of code that I've written that takes in some, when invoked from the command line, it's pretty simple. When invoked from a command line, it has arguments coming in, and then it does some operations. So what I do is I get a list of VIs that have changed in source code control, and then I run a VI Analyzer configuration on those changed files in order to check for performance, style, all the things we talked about earlier. So you're basically writing your own custom behaviors, your own custom actions, such that, when invoked from a command line, you do some testing, some building, etc. So that's kind of like the how part one, the how part two. So what are we going to do with our command line? Well, we're going to automate some testing. So let's go through each of those things in the list one by one. VI Analyzer. VI Analyzer has an API. Allows you to create an analysis task and select the tests that you want to run and select the VIs that you want to run the tests on and then run them, and you get a report out of it. So that's kind of the stuff you want to do 90% of the time when you're testing your VIs. There's a link down there. The slides will be available after the event. But there's a link down there to an hour-long presentation I did on VI Analyzer and automating it. So if you want to analyze one or more VIs using a specific configuration, that's the LabVIEW code for it. That will run VI Analyzer. You provide it a config file. It will run VI Analyzer against a number of VIs of which you've provided the input in the top, VIs to be analyzed. It will analyze those VIs, produce a report, give you an outcome. Maybe you don't have a VI Analyzer configuration though. Well, even better, you can actually just give it a list of VIs that you want to analyze and a list of tests that you wish to perform on those VIs, and it will run. So we're not writing huge amounts of code to be able to automate these things. We've dropped down, 7 VIs down there, and now we've got something that we can use to analyze our code. Unit test framework, it's even simpler. 2 VIs, there you go. I've got a unit test framework API. I provide it with a path to a LabVIEW project that contains some unit tests, and it runs those unit tests and produces a report if we wish, or opens the report window also. So pretty straightforward. So we've done 2 things. We've done static code analysis and we've done unit testing so far. Application builder. So if we've ever built a PPL, a source distribution, an executable, we've used application builder. Thing on the left-hand side that you see there, but it also has an API. If we want to automatically trigger the building of a PPL, the building of an executable, we can absolutely do so using the application builder API. Similar to what we just saw before, we can use those VIs, trigger a build. So we might do some testing, some unit testing, some VI Analyzer testing, and then if those tests pass, we might choose to build our executable. We might choose to build our PPL. What else can we automate? Do you ever build packages? Do you have reuse libraries that you want to build? There's an API for VI Package Manager. I believe now you can do that with the Community Edition and the Pro version. I think the free version, you still can't do that, but the Community Edition allows you to use the VI Package Manager API, and it's a fairly extensive API. It doesn't just allow you to build packages, it allows you to install packages, uninstall packages, build package configurations, super useful. So if as part of your process, you want to run unit tests, VI Analyzer tests, build the executable, but in order to build the executable, you need Q's library or you need Sam's library. You could have part of your process, you could automate the installation of those packages prior to building your executable. Yeah, and that's how you can do that, preparing your machine to be able to do those builds. And there's a huge link there, a knowledge base article on how you can do that. Who uses TestStand? Okay, so all of the things we talked about with VI Analyzer, looking at the style, looking at the dangerous constructs, the performance, you can do all of those things in TestStand. So TestStand has a tool called Sequence Analyzer, and it allows you to apply rules to your TestStand sequences to check for certain things that might affect performance, things that might be dangerous if certain environmental parameters change. Find dangerous constructs. So there on the right-hand side, I've got a couple of tests and I was doing some testing, so I basically right-clicked on those tests and said force to pass. And that could be dangerous because if I deployed that test sequence, it is always going to pass. So I want a sequence analyzer that will run and look for that and make sure that I'm not about to deploy something that contains that potentially dangerous setting. If you're a little bit skeptical, I once worked with a customer who had accidentally set force pass and they were having fantastic yields in production. Everything was wonderful. And then I went in as the consultant and fixed it and the yield plummeted. And they said I was the most stupid LabVIEW TestStand developer they'd ever met. But those are the things that you might want to test for using Sequence Analyzer. Guess what? Sequence Analyzer has a command line interface. We can run that automatically on our code. So we make a change to our TestStand sequence. The first thing that happens is we analyze it. We look for brain dead stuff like that I may have done, and we can check for it. And if it fails those tests, fails those checks, then we don't want to deploy our system. We don't want to build our TestStand deployment. So we can check for those things. And then finally, if it was successful and it passed the sequence analyzer tests, then the actual act of deploying a TestStand system using the TestStand deployment utility, then we can absolutely do that. And you'll have noticed there's links on each of those pages to a lot of information to show you actually how to do that in depth. So the actual act of deploying, which, you know, that's non-trivial, but we could, once we've figured out how we're going to deploy our system, then we can automate it. Okay, so the how part 3, what I call local automation. This is the baby steps. If you've never done CI/CD before, this is a great way to dip a toe into the water and actually figure out how you're going to do it. So here's a thought. How about testing before we actually commit? So CI/CD kind of promises this vision of, I'm working on some code, I've made a code change, I push that to a repository somewhere in the cloud or in a server room or somewhere, and it gets tested and it gets built and some output comes from that. But that requires infrastructure, it requires kind of detailed knowledge. I think there's some steps that you can take first before you do that and actually start to test as you are committing code locally. Now, you're not going to want to test everything because every single commit then is going to result in huge VI analyzer tests that take some time. But you could absolutely check some basic things. We could check that we're not using current VI's path when wired to a build path function. We could check that we don't have VIs that we're trying to commit that are still called untitled 2 or have the default VI icon. We could check that. I think there's lots of value in that. One, it's a toe in the water. It's a way of getting started with CI/CD, but also bad code that gets committed tends to stay committed and not really get fixed. If you look in your repos, go back to the office, have a look and see if you can see an untitled 1, an untitled 2 in your repo. Stuff like that does make it in there. If you can catch that earlier, then great, what's not to like? And then we could also check for some style things, making sure you don't have wires going under structures or wires running from right to left. So rapid feedback means fewer changes to rework. So why not test the code before we commit to our actual feature branch? Let's check test on commit. So blah, blah, blah. So how do we do that? If you have a Git repository local, you may have spotted that you have a .git folder. Who's ever spotted a .git folder alongside their code and thought, okay, who knew what it did or what it was there for? Okay, a smaller group, but some people have still spotted it. So obviously that's got the copies, the working copies of the code and the differential changes that have been made to your code over time. But it's also got what are called hook scripts in there. Hook scripts are scripts that can be used to detail actions to be performed when certain things happen. So if we look at, I know it's a little bit small, but if I read out some of those things, we've got pre-merge, pre-push, pre-commit. They're all events, things that happen in the process of using source code control. And the one I'm interested in particularly is pre-commit. I want to run a script before my commit is made to the repository, and I want that script to detail a number of tests. I want it to run VI Analyzer. I want it to run perhaps my unit tests so that I don't end up committing untitled 2 or a VI without an icon. I want it to do that when I'm making the commit. So one thing you may notice is each of those script files has a .sample extension. They're all disabled by default. When you install Git, none of the Git hooks are enabled. We can enable them by simply removing the .sample from the file name, and it becomes activated. Anything that we've written inside of that script file, any bash script that we've written inside of that script file will be executed. So we could write some scripts with command line arguments that we could pass to our VI Analyzer, our VI tester, our application builder in order to perform actions when we commit code. So things we might want to do. This might be an example of a workflow. This is absolutely not the must way of doing it, but this is a suggestion. We could do pre-commit hook. So I've decided I want to commit something. We could then get a list of the changed files, because we don't want to test everything. We just want to test the things that have changed. And then we want to run VI Analyzer on those changed things. If it passes VI Analyzer, we commit the code to our repository. If it fails VI Analyzer, we reject the commit and say, hey, go fix your lousy code. Go fix your untitled 2.vi. Okay, that's an example workflow that we could do, those steps there. And we're going to do that in a second. And we can obviously, we can use some functions to actually find out what has changed fairly easily. We can send a command line argument, command line git status and find out, okay, what's changed, and then just test the things that have changed. By the way, all of the example code that you're about to see will be provided, so you can actually use that as a starting point for your own dipping a toe in the water. So let's have a look at what that actually looks like. So first example I've got is, I've got some code. I've got a mouse that doesn't work, but so I've got some code. So what I've got here is some LabVIEW code, and then I've got a little CI helper, as I've called it. I think for a LabVIEW demonstration, I would have started LabVIEW. So I've got some LabVIEW code, and I've got a VI that's got some block diagram issues, and I've got a VI that's got some front panel issues. We'll take a look at them as soon as LabVIEW's started, which it has. So let's have a look at the VI with block diagram issues. These are just very trivial examples. Can anybody see anything wrong with that one? Okay, so we've got a wire that's running underneath an object, and on my front panel, I've got some non-transparent control labels. I hate non-transparent control labels, so I want to fail the commit if I've got those issues wrong with my code. I've got a VI Analyzer configuration, so I'm cheating. I've got a VI Analyzer configuration there. It is only testing for wires under objects and non-transparent control labels, just in the interests of time. This is a demo after all. So I've got some code, it's got some problems with it, and I want to stop that code being tested. I've also got a little, what I'd call a CI helper. It's just a little bit of code that is, let's have a look at it. It's just a little bit of code, just written for this demo, that is going to be run from a command line, and it's got some arguments going into it, such as, do you just want to test files that have changed? Do you want to run VI Analyzer? And then it actually calls the VI Analyzer API and tests some code. That's the same code that we saw earlier in the slide. So The demo that we're going to do now is I'm going to try and commit that bad code. So that's my little helper. I've got a script, a pre-commit script that's activated to pass some arguments to that CI helper application that you just saw. So let's commit that code. So let's launch a bash shell. Let's see what our... So we've got two VIs. They've already been modified. We know that they've got problems. One's got a wire underneath an object. The other one's got non-transparent labels. So let's add that and let's commit. Okay. And the pre-commit script has run this time. And yeah, remember that, just run. So it's now going to run that VI. I've made a commit. It's automatically run that VI. It's going to fail for those things. Didn't get it to close itself. And let's see what the status is. So yeah, it's still modified. It didn't commit that code. Okay. It rejected that code. We can put messages up there saying why, etc. It's just to kind of show the mechanism of it. So let's go and fix those things. So let's fix that code. So it's kind of fixed. Control U. Depends how you look at it. And then let's get rid of the. You can tell I'm old school, not using quick drop or auto wiring tool. Darren is. I can imagine what he would be saying by now. So let's go transparent. Let's go transparent. So we just fixed those two things. So we should have code now that is good to go. So let's go back to our, let's add, let's commit. Let's see if it makes it in this time. Oh yeah, we know. Run. They say never work with children or animals or live LabVIEW demos. And there we go. It's asking us for the commit message. It accepted the commit. So this time we fixed the bad code. I made the commit. We ran the tests and they passed the second time. And it allowed that code now to be committed. So I can put fixed my crummy code. There we go. And we've made the commit. So that's kind of one example. Another example that we might want to do is to actually build something. So this time, I've got an actual application. So here we've got a DQMH module and a driver. And my DQMH module is built into an executable. So let's go and see how we're doing for time. My DQMH module is built into an executable, and the driver is built into a PPL. So let's just show that running for a second. So let me run my exe. So there it is. I've just used the DQMH tester and built it into an executable. I'm going to browse for the driver that I want to run. It's a PPL. And I know that I've got a couple of different classes in that PPL. So let's select, oh, I'm at an NI conference, dare I type Keysight? My PC will probably crash now. LV class. Okay, so let's run the DQMH module, and we can see it initialized the Keysight power supply class. I'm going to go and make a change now to the underlying driver code. We're going to change how it identifies itself so that it doesn't say Keysight, and rebuild it as part of making that change. So I'm just going to make the code change, and it's automatically going to rebuild my PPL and therefore change the behavior of my executable. So let's just stop that for a second and close that. Let's close that down. We could have left it open, but so let's go and make a code change. So let's go into our driver library, and let's find the Keysight power supply and the identify VI, the thing that passes that message back saying what it was. I'm going to change it. Let's change it. Instead of being Keysight, I could be cruel, but I'm not. I'm just going to put I could be very unprofessional. Okay, so I've made my change. I've made my code change. I am now going to build my PPL, but in order to do that, I've got to try and do the commit. So we saw that popped up with KeySite in the status bar. Let's do that. Let's do that commit. Let's commit that changed code. So let's just do a git status to make sure that we see a change. Yeah, and the identify. Sorry, it's really dull. Trust me, that says identify.vi there in that shade of red. So now we're going to do a commit. And we can see it's now run our pre-commit script. This pre-commit script is different to the last one. Instead of running VI Analyzer, it's actually going to run the build specification and rebuild my PPL. Okay, so it's doing some stuff. And I probably forgot to close it again, but we'll give it a second. Because PPL building. Yeah, oh, okay, there we go. And it finished. And it's asking me to make the quick commit, so I'm going to do rebuild, or let's change it to modified identify. Okay, so I made a commit, I made a change. It's hopefully rebuilt the PPL. So let's go back to the demo executable. Let's run it again and let's see if it's got the new PPL. So let's browse for the PPL, same place. Let's make sure that we're specifying the KeySite. Let's run that. And, oh, I did something wrong in that. Let's just make sure was there a typo in that? Yeah. There you go, an inferior product. So I just made a code change and I committed that change, but the act of committing resulted in my PPL being rebuilt and my executable now having new behavior. So kind of those first initial steps into CI/CD. I mentioned at the start that this is available for TestStand as well. So let's see something quickly that we might want to do with TestStand. So let's go back up a level. And in this case, we've got a test sequence. So in this case, we've got a test sequence. And final functional test.seq, and I've got a TestStand sequence analyzer configuration. That's a list of tests that I want to apply to my sequence in order to apply rules to it to make sure that it doesn't have crazy things like force to pass, force to fail. Guess what? This one does have force pass, force fail in there. So let's just have a quick look at that. We're doing on time, we're all right. Oh, there's a mistake, launching TestStand. I should have had that one running as well. Gosh, what was I thinking? That actually launched. For those who've seen a presentation before, you'll have noticed I've been a lifelong Mac user. This Windows experiment is 2 weeks old. So, okay, let's just run a command line and see if we can get the test to run. Okay. So let's git status. Okay, so we've got a modification already, so I can commit that sequence and it's going to run sequence analyzer. I can tell you, let's spoil the surprise, there's already something in that sequence that I don't like. It's already got a test that is set to force pass, potentially dangerous, might result in our yield being 100%. So let's go and commit that. If I could spell. Okay, my pre-commit hook has run. You just saw Sequence Analyzer run, and the commit didn't happen. And we've got a Sequence Analyzer report that's been created there automatically. If we open that, we can see, eventually, we can see nothing. The point is, we didn't commit. It failed the test, and it prevented me from committing something that was potentially dangerous. Okay, so these are the baby steps that I talked about. So let's just go back. So we've done pre-commit. We've run VI Analyzer. We've run our build specification. If we're a TestStand person, we've run Sequence Analyzer. We've run the TestStand build deployment utility. Then the final part is, okay, we've done the baby steps. We've learned how command line interfaces work. Now we want to go to the nirvana. We're really going to do CI/CD. So we're going to do automation with build servers. So let's just revisit why we're going to do that. We want to integrate multiple changes from multiple developers rapidly. Me and Sam are working on the same project. I don't want to wait for him to finish and make his code changes. I'm going to make my changes and push them to the repo. He's going to pull from that repo and get the changes. We want that kind of rapid feedback. We want to know quickly if one of us has introduced a bug. We want to do testing and building asynchronously. I don't want to sit there while VI Analyzer goes through the 106 inbuilt VI Analyzer tests. It's not a case of you go and make a coffee. You could go and have lunch. So I want to carry on working and have that testing happen asynchronously. And we want to integrate those changes as we're working, not after 2 years when we find out that we've had 20 people working on something and it's not going to work. We want to do that very rapidly. So we're going to have some kind of CI/CD infrastructure. That's probably going to look something. There's different variations on a theme, but it's going to look something like that. We've got some developers, and they push code to a hosted repository. That might be cloud hosted. That might be locally hosted, but they're going to push that code to a repository. It might be GitHub. It might be Azure DevOps. It might be GitLab, but they're going to push that code to a repository. That repository is going to contain, I'm not going to do a deep dive on this, but that repository is going to contain something called a YAML file that describes a series of steps that we want to perform when things happen. Doesn't that seem familiar with Git hooks? That's why I'm kind of telling you to get familiar with the act of scripting those activities. Get familiar with the act of actually writing scripts, and it will make the transition to something like this easier. It's not going to be easy, but it will at least, you will be more comfortable. So you're using something like GitHub, GitLab, Azure, and you're going to define this YAML file, which is a list of actions, things you want to perform when certain things happen. So previously we were saying, I want to do VI Analyzer, VI Tester, build my PPL when I commit. In this case, we might want to do run VI Tester, run VI Analyzer, build my PPL when somebody pushes or when somebody tries to merge into the main branch. It's still a list of tasks associated with an event, okay? So in this case, when I push my code, I want to build, I want to test and display a result. That act of testing, building, displaying a result happens on another machine, okay? That might be a virtual machine. It might be a cloud-hosted virtual PC. It could be a Docker container if you've heard some of the presentations. There's lots of options. This is just a kind of a general topology that you might see, just to get you used to it. On that machine, you will have something called a runner. You'll have heard that term. I'm not going to explain how to set up runners. I've got some links at the end. Sam has got a great article on different options there. But it might be something like GitHub Actions. It might be Jenkins. I'm sure some of you have heard of Jenkins. And that's going to perform the act of building, testing, and displaying a result. So we might not have a VM. We might have a Docker container. Like I said, it's a next step on from that local integration. YAML, really quickly, it's the language, the scripting language, if you will, that's used by most CI/CD systems. It defines configurations, it defines tasks. A couple of points on YAML. It's human readable, it's case sensitive, it's white space sensitive, its structure is defined by indentation, it doesn't recognize tabbed indentation. It's a pain in the arse. It's a necessary evil, sadly. So that's why I say baby steps. If you throw yourself in to try and build some kind of infrastructure like that and start dealing with YAML files and script files before you've dipped that toe in the water and got used to scripting, got used to command line arguments, you're probably going to give up. Sam?
Yeah, there's even more issues with YAML than that too, like escaping characters and stuff like that, and spaces and arguments, and it's a whole ball game.
But Sam, if you take away the hope, then
It's fun.
Well, that's one thing I would say. You've outlined a very iterative approach. When you're doing this, do it all very iteratively. Like, don't write your entire YAML file, write a little bit, do one job, get that to run, then write the next job, that type of stuff.
Or even write a YAML file that calls a batch script to PowerShell or something else. Keep the YAML file simple. Do the work in something where, A, there's more documentation on how to write a batch file, how to write a PowerShell file. There are even tools that will parse those and build those for you. So take an iterative step-by-step approach. Sergio?
So I did a PowerShell-based automation based only on ChatGPT. So I don't know YAML that well. So there is a way that if it's difficult for you, you have never done it, you're going to be surprised at what you can achieve by that. That doesn't mean that you can just do all CI/CD on ChatGPT. No, but it is a start. Like if you have a problem, put it there. It's going to tell you, give you a better way of that. That's working or it's not working.
Yeah, what he said. Okay, so I'm not going to do a live demo of this for reasons. I'm just going to show you what that might look like in a quick 2-minute video before we get to the end of this session. So what have I got? I've got my my driver code that you saw earlier. I'm going to go and do a git status, and you'll see there's nothing to commit. There's no changes. Let's have a little look in the source folder, and we can see my driver VIs. There's my inferior product library, and that LVlib has a build specification to create a PPL. And my PPL has a defined output where it should be built to, and there we go. What I'm now going to do is I'm going to make a change to that code locally, and that's going to result in a YAML script running and something happening. So we've seen what code I've got locally. Let's take a look at my, let's have a look at my GitHub server. There's my code. I've got a YAML file. All my YAML file is going to do is check out the code and run a build specification. Okay, so I've got a YAML file. I'm not going to even look at the YAML file. So let's finally see my VM. My VM is the place. Come on, Chris, look at the VM. There it is. So there's my VM. It has a runner that's going to listen for activities on the server, such as me pushing code, and then it's going to run the build specification and build my PPL. So let me zip ahead a little bit. Or maybe not, that's dangerous. So you can see at the minute, the demo PPL's directory is empty. The NI Connect demo directory is empty. We're now going to run the runner. I'm running it manually so you can see what happens. It's connected to GitHub and it's listening for jobs. It's waiting for me to do something and trigger some action. So let's go back and let's make a change to some code. So let's go into the inferior product. I'm going to get sued, aren't I? So let's just move something in the VI. Let's just move just enough to trigger a change. Let's save that change and let's push that code to the repository. So here's my command line interface. Like I say, I like working with that. I just find it quicker. So let's do git commit. Let's commit that code, edit add a commit comment, and push that to the server. So we're going to do a commit and then a push. So now that code is being pushed to the server, which is going to trigger. See, that directory is empty, that directory is empty, nothing's happened. The runner's still waiting. I'm going to go back to that, push the changes to the server. We should see the job start to run. I think I actually flick across to the server to see the job. Okay, so we've pushed the code. If we go back to that, we can see now it started to run the job. So it's processing that YAML file. It's looking at the list of tasks and performing them one by one. We can see the actual run, the job is running now in GitHub. And then when we go back to the VM in a second, we'll see LabVIEW spring into action and it actually build the PPL, check out the code and build the PPL that we wanted. I, in parallel, could be still making code changes. This is the kind of the asynchronous part of it. I could be doing some work, making some code changes. There we go, LabVIEW fired up. It's going to build my PPL in a second. Videos always seem slower when you're watching them back, don't they? So simple bit of LabVIEW code just to build my PPL. Desperately needs a UI. It was just built for this demo. Okay, it was successful. So if we now look in this directory, we could see it checked out the latest code. It ran the PPL build specification, which I hopefully will look at in a second. So you can see it checked out the code. And if I go to the demo PPL, if I click on it, click, there we go. And it built the PPL. Okay, so that's kind of where you might want to get to. But as I said right at the very beginning, baby steps. So just returning really quickly, we're done. So there's some new stuff in LabVIEW. You've maybe have already seen from Christina's presentation, but there's some enhancements to help work with some of these collaborative tools. The best slide to look at is this, honestly. There's some amazing resources here. So Sam here at the front, Sam Taggart, SAS Workshops. If you want to talk CI/CD and kind of get more information and just get advice or hire him, absolutely come and talk to Sam. He does this thing day in and day out. It's his bread and butter. There's some presentations there on even why bother with continuous integration from somebody. Chris Woodhams runs a business in the UK. It's the livelihood of these people and they're doing it day in and day out. It's their bread and butter. So absolutely come and talk to these people. There's tons of resources embedded in the presentation. So as soon as the event's over, you'll get an email from NI with links to all of the materials, links to all the resources. Seek that out, look at these resources and dip that toe in the water. Thank you very much. Any questions? Question?
So my question is in VI analyzer part. So you created the VIA config file, right?
Yes.
And is it tied to the project?
So a VI analyzer, it can be tied to a project or it can be independent of a project. You don't have to define a project in a VI analyzer configuration. You can define no project and you can just define a list of tests. Or you can, if I looked at the code really quickly, got it, so there's a lot of slides. There we go. So you'll see, I've got a path to a configuration file coming in, which has got a list of VIs to test and the tests to perform. The first thing I do is I remove all the items from that VI analyzer config. So I remove all of the VIs, but leave the list of tests in there, and then give it a new list of VIs to be tested. So there's lots of different ways you can do that, but yeah, absolutely.
So that's where I had the structure.
Yeah. Yeah, so that code will be provided so you can use that as your starting point.
So the last part of the workflow that you talked about with the YAML script, you actually have a separate VM with its own set of own LabVIEW installation on it.
I did.
That handles the building.
Yeah, absolutely.
Cool. That's cool.
So I was wondering how you handle this for like multiple projects. You have a YAML file is that specific to a project, or do you have a different build servers, or you have some logic to look at different projects or different build specs or something?
All of the above, honestly. I have yet to find a one-size-fits-all solution. I'd be interested to hear what Sam's got to say. I've typically had a YAML file for a project. I've tried to make it more generic for YAML files for reuse libraries that need to get rebuilt. You've seen the YAML file, right? I'm not a YAML guru by any stretch, so I stick with what's simple. I don't have a good answer. I'm sorry, Jeff.
I actually wasn't going to answer that question, but I will. I have some templates, so we can talk later. But I just wanted to say, excellent presentation.
Thank you.
I very much like it. I like the iterative approach. If you go to set up the servers and stuff, the hard part is getting it talking to each other. And once you get that, then you can start. So don't feel like you have to have everything. Like Chris said, do it iteratively. If you just have like one build script and you run your build script, that's great. Then adding unit tests is just an easy step after that. So don't get overwhelmed. That would be
Okay,
the big
cool. I think we're out of time. Thank you.